My name is Michele Mackenzie. I'm a principal analyst with Analysys Mason. For those of you that don't know Analysys Mason, we're a management consulting company. We have a consulting side of the house, obviously, but I work on the research side. And I'm focused on IoT and private networks. So I'm going to start with my presentation, and then you'll hear from the gentleman here. And then at the end, we'll open up for a panel session, and hopefully you'll have lots of questions ready for that. Okay, so for my part, I'll be looking to begin with at key trends in private network adoption, and I'll be sharing with you some of the findings from our trackers. Then we'll take a look at some of the different network models that are emerging. And then we'll have a look at some of the enterprise requirements in terms of their technical requirements as well as their commercial requirements. And I'll be sharing with you here some of the findings from our research. So, to begin with, and this is information from our tracker, and I should say that the tracker collects public announcements. So there will be more private networks out there, but if they're not, there's not information in the public domain, then obviously it's not in the tracker. So this is really focusing on a selection of 301 networks where we have information about the enterprise that is deploying the network, the sector they're in, what they're deploying the network for, and who's supplying that network. And as you can see here, it's the manufacturing sector that is leading the way at the moment in terms of the number of public announcements. And that's closely followed by transport, where we're seeing a great deal of interest for private LTE and private 5G, especially in transport hubs such as airports and ports and so on. And then that's followed by mining, oil and gas. So we've seen a number of deployments and a number of announcements in that sector. And then so on. You can see that there have been a few in utilities and public sector and so on. And I think what's interesting here as well is that we're very much seeing more interest or interest growing in 5G. So obviously some of these networks have been around for some time now. And LTE was the main network generation that was deployed, but now we're seeing growth in 5G. And just to give you an idea of the number of announcements, back in 2020, around 17% of those networks were 5G. That grew to around 37% in 2021. And now our latest results are showing 44% of those networks are 5G. So interest in 5G and awareness of 5G is growing. Now, what are these networks being used for? It's quite difficult to get good data on exactly what they're being used for, and that's why we have a large number here, which are general connectivity. But if we dig a bit deeper into some of those announcements, by general connectivity, some of the enterprises are looking to support large volumes of data. And this may be part of their digital transformation strategy, where they're we've spoken to companies such as a large steelworks, where they're looking to use that data from their different plants and to use it to improve their sort of business processes and become more efficient. Similarly, we've seen some of that in healthcare as well. So with hospitals, medical imaging, for example, they're producing large volumes of data, and they're deploying private LTE, private 5G to help support that. But we're also seeing quite a big focus on IoT in these announcements. So it's not really about supporting smartphones and sort of general communications, but some of those are sort of more specific operational use cases. Asset tracking is a big one, but we're seeing also a lot of interest in automated guided vehicles, AGVs, for example. So I think what we typically see is that an enterprise will deploy a private LTE or 5G network, typically with a sort of anchor use case in mind. It will start with one, but then they're looking further ahead at what other applications can they support on that network. And it's only the beginning, really. I mean, these are sort of emerging, this is a sort of emerging technology. Enterprises are switching from their sort of legacy existing networks to this, and they're exploring what they can do with private LTE and 5G. Now, I wanted to speak briefly about some of the network deployment models. Something that's come out of our research when we speak to enterprises, and we conducted a survey among enterprises about a year ago now, is that there's quite a lot of confusion around the different deployment models. Now, we see that, very broadly speaking, there are three main deployment models. The first one is the dedicated on-premise model, where the enterprise will deploy both a radio network and core network on-premise, and it's solely for that enterprise's use. None of the resources are shared. And in some cases, they may have their own spectrum, industrial spectrum that's been awarded in some countries, and in others, they will depend on mobile network operators for that spectrum. And we think that well over 95%, it's probably closer to 98, 99% of networks today, of private networks, are probably fully dedicated on-premise. But there are some emerging trends for other network deployment models. One in the middle that we're calling hybrid, where an enterprise may work with a mobile network operator and use some of the public network assets to support their private implementation. We've seen a few examples of that. Deutsche Telekom with Ericsson, for example, have looked at that. And I think where we're seeing sort of more activity in that is in China, where the mobile network operators are very active in supporting enterprises for operational use cases. And then the final model is a bit more future-looking, the slicing model. And as network operators roll out and introduce 5G standalone and so on, they're looking at how they can offer an enterprise a slice of their network tailored to enterprise needs to support their operational use cases. Now, the main point I want to make with this slide is that there's a lot of confusion around these different models among enterprises. So those that we've surveyed, we tried to give very clear definitions, but it's not clear what the benefits or advantages and disadvantages of each model are. So I think there's still a lot of education around this that needs to be done by the industry. And from that survey I mentioned, which was around a year ago, we interviewed enterprises, or we surveyed enterprises rather, in different industries, different verticals. And we gave them the definitions of these different network deployment models and tried to gauge exactly what their preference would be and where they see the advantages of each model. And just to pick out a few here, I think utilities is an interesting one because they're looking for networks that will be fully dedicated, on-premise networks, totally private, not using public network assets. And I think that's a reflection of the utilities industry in terms of, they're dealing with mission-critical assets. The need for security is high, so they typically want control over the network. Obviously, these attitudes might change over time, as I say, as we educate the market around the different models. Just to pick out another one, entertainment and retail, there was probably sort of more interest there, more openness towards a hybrid or slicing model. It's quite difficult for enterprises at this point in time to see the benefits of each. But, you know, in terms of cost benefits, if it's understood that a hybrid or slicing model could be a more cost-effective option, then, you know, we'll start to see some of these different verticals maybe take more of an interest. And then, you know, in terms of the other one to point out maybe is transport, where it was pretty even among the transport respondents or respondents from the transport sector, where there were different needs. Obviously, in terms of coverage, some of those respondents saw a public network as a much better option. Now, just to sort of take a quick look at what's driving demand among enterprises. And this comes from some of that survey work, but also our broader research speaking to enterprises around their different requirements. So I think, you know, one of the sort of top drivers that's often mentioned is the use cases and what they're looking to support on the network. And very often, you know, the main takeaway that we get from this is that their current networks cannot support some of the new use cases they want to deploy. So I mentioned AGVs earlier, automated guided vehicles, a requirement for mobility, and we often hear that Wi-Fi isn't good enough to support those requirements. But there are many others, so use cases is a main driver. Spectrum availability. So we're seeing many regulators now across different countries making spectrum available for industrial use. We've seen that in Europe, in Germany, for example, in the UK, but also in the US with CBRS spectrum, shared spectrum. So these new spectrum models are really driving interest from some sectors that perhaps wouldn't have been so interested in cellular networks before, because they want to retain control over their network and their spectrum and so on. Then there's network efficiency. So some of the companies we speak to are looking really at consolidating the number of networks that they have in place to support their different use cases. Interestingly, I was on a panel last year for Fierce Wireless looking at, and it was all about utilities, and one of the large US utility companies, Ameren, on that panel said that they currently have 20 networks, you know, Tetra, all different types of network, and they're looking at how they can rationalize that number. Then there's government stimulus. So some of this has come about, obviously, because of the pandemic, but governments are making stimulus funding available, and some of that are to support new industry requirements and digitalization of industry. So there is an opportunity to take advantage of some of that funding. And then regulation, these networks are seen as possibly a driver to comply with national regulation around health and safety, for example, around security, and so on. Now, as I said, we've spoken to a number of enterprises over the last couple of years around different requirements. There are still barriers to private LTE and 5G. Lots of drivers, but also still lots of challenges that the industry has to overcome. Some of this is around the obviously there are substitutes available, alternative technologies, and Wi-Fi 6 is one of those that's often cited as, this is perfectly adequate, suitable for our requirements. Long life cycles is another barrier to adoption. I mean, some factories are in place for 20 years. They have networks that have been in place or, maybe for 5, 10, 15 years. So there is this sort of natural life cycle and waiting for that to come to an end for them to renew and move on to the next generation of technologies. And I think this other quote from a utility company sort of reinforces a little bit what I said earlier. They are, I think it's more of a naturally conservative industry, and they don't see the public network model as meeting their requirements. And some of those perceptions are based on earlier experiences of working with the public network to support some of their use cases. Now, just on technical requirements of some of those enterprises, I think what came out of our survey and some of our conversations with enterprises is that there is growing awareness of 5G and what it can do. Not all of the enterprises that we spoke to have deployed a 5G network, but awareness is growing. And when we spoke to enterprises, they often cite some of these attributes as to why they would look at deploying a private LTE or 5G network. So we saw there that there was a greater awareness of the technical attributes and what that could deliver. Now, again, that's not based on all of those enterprises that we spoke to having deployed one, but definitely there's some positive signs there in terms of what they understood about 5G. But if we look at the commercial requirements, here is where we saw a lot more of a mismatch, if you like, between what the companies, the enterprises wanted from private LTE 5G. And again, it threw up some of those barriers as to why they saw it as a more challenging technology to deploy. Not least of all, I mean, cost was mentioned. And we typically hear that, well, we don't typically hear, but we have heard that, Wi-Fi is significantly less expensive than private LTE 5G. Sometimes we hear by a factor of 3, a factor of 5. It's very mixed depending on who we're speaking to. But cost is a constant theme that is seen as a challenge. I think I won't go, for the sake of time, I won't go into all of these, and I've mentioned replacement cycles, but ecosystem is another area where there is a challenge in terms of device availability, devices that can meet the requirements of the different vertical sectors. So again, there's a lot more education that needs to be done around that. And then just finally, I've included an example here of a company that has deployed a private LTE network. And it was really just to highlight some of those drivers that I've spoken about. In the case of Hub One, the specialist systems integrator, they deployed the private LTE network at the 3 Parisian airports. And it was interesting to speak to them about the different motivations for deploying cellular. So one of their key motivations was they were looking to consolidate the number of networks. They wanted a homogeneous network to support their operational requirements. There was also a big focus on IoT and supporting new use cases there. I won't read out the whole slide or talk about all of it in the interest of time, but I think you're going to have the slides afterwards, so you'll be able to take a closer look at that. So just to wrap up, so the three sort of key takeaways from this presentation is that we are seeing demand growing and awareness of private LTE and 5G. The deployment models are not well understood, so the industry still has a lot to do in that respect of raising awareness and educating enterprises around the different deployment models. And I think the final one is that commercial challenges especially remain, and they still need to be addressed. But on that note, I'm going to hand over to our next speaker, which is, so I think Andrew still isn't here from BAI. He's here? Is he? Oh, you're here. Okay. Would you like to? Sorry, I didn't know you'd arrived. All right.
Hello, good afternoon. My name is Andy Conway. I'm the Director of Solutions and Innovation at BAI Communications, Broadcast Australia International. As you can probably tell from my accent, I'm not Australian, I'm from Yorkshire. And apologies that I was a little bit late to this venue. Got caught in a flash flood actually in Richmond, so all the tubes have stopped running. But I'm sure you'll all be okay later on this afternoon. So the title of my presentation today is making transport smarter, making cities smarter. So the two aspects I'd like to touch upon. First of all, talking a little bit about small cells, given that this is the Small Cells World Summit, and then moving on to some applications as well around private network technology, particularly from a smart city perspective. So, who are BAI, Broadcast Australia International? We're not a household name. We've been around for nearly 100 years, so our heritage is in Australia, where we run the broadcast network, the terrestrial network, as well as running the emergency network in New South Wales. But around 20 to 25 years ago, we branched out into communications for transit systems, transport networks. And here you'll see on the slide a couple of our case studies around the world. We first moved into Hong Kong about 25 years ago, so we're on our fourth generation of tech there on the underground, started on 2G, 3G, 4G, and now rolling out 5G tech on that transit system. And then we moved into New York, where we run a company called Transit Wireless that deploys cellular and Wi-Fi on the underground network as a neutral host construct. And then we're doing something similar in Toronto, in Canada. And then finally there's the quadrant that happened for us last summer when we got the news that we were, won the partnership with TfL, which is a 20 plus 5-year concession as a neutral host to provide cellular network services and advanced connectivity on the underground. So we got that good news last summer. So I would say BAI really has three sort of like key business models that it works on as a neutral host. First of all, you see here, connected transit, which I'll talk about briefly. And then connected venues with our partner organizations that we've recently acquired, Mobility in the US and Villicom here in the UK and Ireland. And then finally, connected cities and connected communities. So what you'll see here, for example, is the sort of like the teams now sort of like looking at the cellular deployment on the London Underground. That's 2G, 3G, 4G, and 5G connectivity. Already there's 7 or 8 stations that are live from an initial pilot build, but we'll be rolling out service to approximately 130 stations. It's about 50% of the London Underground estate is underground, and that will be done over the next couple of years to provide that connectivity on the underground. So it's cellular service and it's a Wi-Fi service. Pretty much all of the mobile network operator equipment will be off TfL Prem. So they'll be in a number of data centers, edge data centers. We call them base station hotels, and we'll have a number of them around central London where the mobile network operator kit will reside and then plug into our small cell network. That small cell network is essentially a DAS, a digital DAS system, which is connected throughout the underground, both front of house and back of house, to carry the emergency service network, the 4G ESN as well. And then next springtime as well, we take over the running of the Wi-Fi concession. As you know, today, it's pretty much Wi-Fi only that you get on the underground. You'll get that signal briefly, the doors will close, and you're off, and you know, your connection will drop. But we take over that Wi-Fi system as well next spring. So those are two of the 4 service lines that, you know, really interesting, cellular and Wi-Fi. But I think what presents an even bigger opportunity over the next 2 decades is the ability for BAI, in tandem with TfL, to explore what we're calling the fibre and streetscape service lines. So obviously throughout the underground we'll be having a multiplicity of dark fibre, high count dark fibre, 864 count throughout the tunnels and the stations, and bringing that up into points of presence around the capital. But on top of that basic fibre connectivity, we'll also be able to leverage TfL's streetscape assets, circa 70 to 80,000 streetscape units and assets, poles, bus shelters and the like. Initially, you know, the play there we see is helping the mobile network operators densify their network and, you know, to provide those facilities for small cell usage, both 4G and of course, 5G systems. So we see this as really, you know, one of the most interesting service lines, categories over the next 20 years. So now I'm going to do an about turn and a bit of a pivot. There's a new dot on the map within the BAI universe within the UK, and that's in the northeast of England, in the city of Sunderland. So last October, we announced a deal again with Sunderland City Council. That's a strategic partnership that lasts 20 years. Again, you'll see a recurring theme here with BAI, vis-a-vis perhaps some of the other actors in the marketplace, in that we do like these really long-term time horizons. That's due in part to the fact that we're not listed, we're actually owned practically in our entirety by the Canadian Pension Plan and Investment Board. So we like these really, really long-term deals in order for us to invest properly in the communications networks as a true neutral host. So what are we building up in Sunderland? First of all, we're building 3 networks in one. The 3 networks are all small cell networks. So the first one that we're building is an outdoor 5G small cell network, and that will be a private network that uses the N77 band shared access spectrum from Ofcom, and will provide approximately 1.8 square kilometre outdoor 5G bubble for the city centre. Most of that will be backhauled using dark fibre connectivity to a local data centre. So we're using Open RAN technology, so very small form factor radios on the lampposts of the council, and then all of the clever stuff back in the data centre connected with dark fibre. The second thing that we're doing is we're taking over an outdoor Wi-Fi network, and we're expanding that threefold to cover the whole city centre as a slab with outdoor free Wi-Fi for the citizens of Sunderland, free at the point of use. And then the final small cell network is that we're deploying an IoT network that can cost-effectively connect a number of sensors across the city. Well, actually, in this case, it's not the city within the ring road, it's the entire Sunderland region, so it's 127 square kilometres. And there we've elected to use a LoRaWAN network, a long-range, low-power network, to connect up those sensors across the region. So those are the three small cell networks in one that we're deploying, and those systems will be active later on this summer. The whole reason behind it, of course, is not the technology, although I am a technologist, no apologies there, but it's to create a joint venture with Sunderland Council to start to explore smart city use cases. So we already have, I think, about 18 or 19 really interesting use cases on the boil now to take advantage of those networks. And we're very much the kind of digital partner for Sunderland over this next 20-year period. And as a techie, I just couldn't help slipping this into the deck. So I'm a bit of a small cell spotter. You'll often find me wandering the streets of London. But this is just showing you as well that, it's real. These are some of the pieces of equipment and solutions that actually last week were in our final staging. So I couldn't help taking a few snaps there of some of the Open RAN technology that we're deploying, some of the Wi-Fi technology, the majority of which will be backhauled, as I said, by fiber, but we'll also be using a 60 gigahertz millimeter wave microwave network as well for cells that are hard to reach. And then a LoRaWAN gateway. So I just sort of slipped those into the deck just to make it interesting for me. Having said all of that, it ultimately doesn't matter about the technology. And I think you've probably heard that as a recurring theme in previous presentations today. It's about the business problems or the enterprise problems that you're trying to solve. And for BAI, as a neutral host, it's all about that partnership. So be that in London, where we talk on the one hand transport language to TfL in a very heavily regulated environment, and then on the other side, we talk MNO to our colleagues down the M4 corridor and in London, or whether it's the language then of the council up in the northeast and how we can translate their problems into solutions that leverage the tech. So really, it is all about relationships at the end of the day. And for us, that's what a neutral host is, someone that can provide that long-term infra and work with different partners to provide particular outcomes. I am often asked, what is the real driver for the Sunderland Smart City piece? And, of course, at the heart of it, we're connecting into a 5G standalone core network for that outdoor network. That's powered by Mavenir technology, the Mav Edge switch, which is now activated in a data center up in the northeast. And for us, that can provide private network capability. The previous speaker talked about some of the challenges there. We see that this is it's going to be a real accelerator for IoT and 5G use cases within the northeast. So they're putting together now a really interesting package on how they can attract SMEs and businesses to utilize this advanced network. And we're already seeing a number of quite advanced use cases in the education sector, in the university sector, that are very interested in leveraging a 5G private network, and also manufacturing and logistics, where, already I think yesterday or today, they're talking about the next suite of pilots and trials in terms of automotive logistic technology. And of course, Sunderland's got that very big capability up there with Nissan and Vantec. So we're exploiting and exploring these new use cases extremely rapidly together with the council. But then ultimately, it is all about the outcomes. The outcomes that the council wish to deliver. There's a massive regeneration program up there within the city. Those of you that have been up recently transforming the city centre now. I think there's over £350 million worth, £400 million worth of investment on physical infrastructure, new libraries, new entertainment centres and so on. And essentially what our job is within BAI is to mirror that then with the invisible digital infrastructure that goes alongside that physical infrastructure. And we're speaking a lot with government at the moment about this new model that we've seen in Sunderland, which we think is really pioneering, and having conversations there to see if it's a model that could be adopted elsewhere in the UK. And Sunderland certainly have this strapline in terms of a city where no one and nowhere is left behind. So the final slide really for me, outlining, stitching together today two, on the face of it, quite disparate use cases or reference studies, but actually I think there's a common theme throughout. And really it's all about shared infrastructure first and foremost in difficult to reach places where the business case means that it makes absolute sense for a neutral host to come in and provide that enabling infrastructure. And so, on top of the infra, you have a partner, a trusted partner or a neutral host partner. A lot of work has been done here at, within Small Cells Forum, which BAI are also on the exec board of, to sort of like quantify and record the various neutral host topologies that can work well with small cell networks. And then once you've got to that point, it allows you to densify the network. So whether that's the 50 small cells in Sunderland to provide that outdoor 5G private network, or whether it's the opportunity of thousands and thousands of new small cells in London, leveraging the TfL assets and our dark fibre connectivity. And on top of that, ultimately, once you've got that dense network, then of course you can offer smart city applications and use cases. So that's how we see that you can start from making a transport system or transit system smarter, and then ultimately move out and create a whole smart city construct with councils and authorities. And that's the end of my talk. Thank you very much.
Thank you. So next up, Anthony Magee from ADVA.
Thank you. So I'm ADVA. Just to introduce ourselves briefly, we're a transport vendor typically. A different transport to the transport that Andy's been talking about. So we deal with the bits and bytes that effectively light up the fibre that connect some of these things together. So our background is optical transport, synchronization, but we're going to be talking today about the all-RAN and the enterprise. And first up, I'm going to ask a couple of questions within my slides and try and provide my insight to the answer to those. Around, do enterprise and private networks actually need 5G before we tackle the all-RAN question? So we know that Wi-Fi is really well deployed. It's massively deployed in industry, very widely accepted, comes with a set of features on it that is evolving over time. And if you take a look at the recent standardization roadmap for 802.11 standards, they're mentioning things like IoT, enhanced broadcast, but they start to talk about positioning accuracy, so tracking the location of the user as they move around, or the thing that connects to the Wi-Fi access network. They can track those things to, hopefully, in time, to within less than 1 meter. So clearly, Wi-Fi is going to be there. But in our view, Wi-Fi doesn't have a monopoly on these things. There are other technologies that are going to evolve over time. And I'm sure that if people take a look back in history, they'll have seen a few people talking about 5G, and for some strange reason, they tended to use elephants to do that with. So people referred to the 5G elephant, and in the 5G elephant, they were trying to describe the multiple kind of feature sets that 5G can bring, like low latency, security, tactile services to 5G services and radio services. So my answer to that is, today, Wi-Fi probably is there. Everybody uses it. It's widely deployed. And therefore, do they need 5G and all around? Probably not. They don't need it. But can they benefit from it? And the answer to that, from what I'm hearing in industry, is yes. So we're hearing a lot of customers come and talk to us. It's not that they want to ditch Wi-Fi and move on to 5G. It's just that they're starting to get a feeling that some of their use cases need another technology to support them. So we have people coming to us, asking us, what do you think about 5G? How can we make it work in the private 5G space? And I wanted to just reflect on that briefly to try and understand why they might be coming and asking about 5G in the context of a private network. So for those people that remember 5G and the standardization process, everybody had a presentation with the 5G triangle, where they talked about the different use cases of 5G. And I had a slide that I was invited to the tower with BT to talk about 5G and network slicing. The use cases that we identified at that event were enhanced mobile broadband, ultra-reliable low-latency communications, massive machine-type communications. And the triangle articulated those use cases in the triangle that we've all seen before. Now, I would like to also question at this point whether 5G has led and delivered on its promise. I would probably say right now, no. Do we know what the killer app for 5G is? No. I don't think we do yet. I think we're about to find out in the coming years. So let me reflect on where the applications, in our opinion, are coming from. So what I've tried to do in this slide is break out the different trends that we're seeing as a vendor as to who is deploying 5G. Now, most people that have deployed 5G, and there are lots of 5G. In fact, I think it is probably the fastest generation that's being deployed so far. It's scaled phenomenally fast very early on. It's being deployed typically by the mobile operators. And those mobile operators are deploying public services to the handset. It tends to, when you go through the feature list, it tends to boil down to a set of features associated with speed to the handset and the amount of coverage that you can get within the geographic region. It's obvious that 5G has to be backwards compatible with previous generations of technology. On the other hand, we also have some private people talking to us and private customers coming to the table and saying, how can I use private 5G? When we go through the requirement capture with them, the discussion is very much away from handsets and coverage and speed. It's into machines communicating with each other, tracking the location of things within the network very accurately, tends to turn into a low latency discussion within the enterprise and an interaction with things. So that maybe is a driver to where the killer app may be. So in the previous slide, I showed enhanced mobile broadband. That's probably the MNO public space. The other two areas haven't really been addressed yet, and I think they're on a cusp of being deployed in the coming years. What are the use cases that are going to drive private 5G? So I took a different stab at it. It's Michele. I went to GSMA and looked at their reports, and they break it down as well. I think they identified, as Michele did, that manufacturing is a really key area. They have some other interesting areas: financial services, healthcare, agriculture, mining is one of the areas that I actually disagree with this. I think mining is slightly elevated. I see some mining companies coming to ADVA and ironically asking a transport vendor to help go in and build a 5G network in their mines. So what we're learning about this space is that this is not about deploying a public network. It's about getting private companies that want to do business transformation in their industry, and they want best-of-breed vendors that come with innovative functions that they can use to build a private 5G network. They're not coming and asking, please will you build me a 5G network? It starts with the use case. So we're actually seeing quite an opportunity here. Market opportunity looks very large. We see a lot of the use cases are indoors, some are outdoors, but I think that the reason that we're seeing indoor requests is obviously the reports say that 80% of use is indoors, so it's not a surprise that we're seeing indoor requests. But it tends to be about creative industries and manufacturing plants that we're getting requirements from. What I did is I actually consulted Michele and took some notes from her slide deck. I don't think she showed these slides, but what it does show is that it's an early stage for private 5G, very early days, but the wheels are starting to move. So if you look at the number of 5G networks that are being deployed, it's increasing year on year. What was really interesting to me is to look at who is deploying those. And I was expecting to see the systems integrators as right up there. I was expecting to see the operators leading the charge, but no, it's the network equipment provider, which is where ADVA sit. So maybe that's why we're seeing some people as well. I can concur with Michele's results that vendors are being asked to come and help build private 5G networks. So what I'd like to do now, I've set the scene around private 5G and why it's an interesting area for us. I'd like to just have a look at how you might go about building private 5G networks, some of the challenges you might face in doing that, and also how ADVA might be able to help. So I wanted to take a look, before I go on and just build a bit on why O-RAN we think is a really important area. So the whole thing stems from what we call centralized RAN, which was all about smaller, simpler, lower power edge for the RAN densification. Gaining some improved coordination between the radios in a dense area, that could be really important. But there was also some ideas about getting baseband unit pooling gains and more efficiency from the network by having your baseband units in centralized sites. And O-RAN, in our view, comes and builds on top of that, so it delivers the same C-RAN benefits, but it also starts to build in some new features. So because it's splitting the architecture up with open standardized interfaces, it should lead to vendor diversity. So to get best of breed functions into a private 5G network, it's likely that you're going to get an O-RAN platform that maybe comes from 3 or 4 different vendors. It's not going to be, in our opinion, one single vendor that supplies that. We think that virtualization is going to have some obvious operational gains in how you deploy and maintain and evolve the network, so more of a DevOps life cycle. But we also see O-RAN as a way to help bring down the overall cost of transport. So moving away from CPRI-based interfaces to eCPRI interfaces in small cells is going to really reduce the amount of transport infrastructure, speed and feed that's required. So one of the areas that we've seen as a vendor in regards to how O-RAN is starting to be played around with and explored in industry is one of the projects that we've been involved in is a DCMS project, so Department of Digital Culture, Media and Sport in their 5G testbed and trials program. We're involved in a project that explored the use of 5G in the port industry and logistics, 5G logistics industries. So what we've learned from that project is, first of all, deploying O-RAN is a challenge. It's hard. It's not easy. If it was easy, everybody would be doing it. But there are some real benefits that come from O-RAN. Innovation benefits. So there are some reasons for that. When you break open the architecture and you have best of breed components, you can start to build into the infrastructure functions that allow you to deliver the features that are required by the customer, not just connectivity, but those features associated with location tracking, latency reduction. So the RIC, RAN Intelligent Controller, we think is a really key area for innovation. And we think that by breaking open the architecture, it gives you new interfaces to play with as a vendor that can lead to overall better performance of the network. So all about performance. So we worked with Colt on a private 5G network, and we acted in this capacity as a systems integrator, so one step above transport. We worked with a number of vendors, some of whom are here today. We worked with Airspan on the radio side, the O-RAN side, and we built up a private 5G network in a campus in France. We deployed the O-RAN platform on a virtualized infrastructure, and we built the transport, the compute, the synchronization. By the way, the synchronization piece cannot be neglected. If I don't come onto that later, please ask me about it afterwards. But the private 5G network that we built there, we built it, it performed, it's still in use at the moment. What we found is that there was a lot of challenges, a lot of lessons learned. So I'd want to address those briefly and then tell you what our view is of moving forwards. So the area that we found really challenging is this part here that's hosting the DU platform. So the DU platform is where a lot of the complex radio processing takes place. The location of the DU is a very specific piece. It's very latency sensitive. It's dominated in the all-around field by the use of commercial x86 COTS servers. Everybody refers to those things. It comes with a bit of head scratching when you try to build a private 5G network. So just to give you a flavor of what we've seen in building these networks. First of all, if you want to build a meaningful size network, so something with more than about 3 radios is going to drive more and more compute. You're going to end up with multiple compute shelves. Those compute shelves running really high-end CPU cores probably still aren't enough to run that many radios, so you end up with multiple compute servers to run the resources that are needed. And then because you're deploying multiple servers, you've got duplication of the functions that need to be deployed in each server. So each server needs a synchronization card, needs an acceleration card, it needs a set of interfaces out to the radios. So in terms of duplication of functions, quite high load. We also see some resilience concerns, so connecting from the radio to a specific DU resource drives the need for a front-haul gateway on top of this. And then to get some operational benefits, you have to build that front-haul gateway. And there's also an aggregation function that comes beyond that. The cell site route is deployed. And you end up with overall a form factor challenge because you've got so many parts of the network to build that all-around platform. And that, in effect, leads to an inefficient cost structure. So the ADVA approach to this, because we think that private 5G is a really interesting space and we think it's going to be hot, is we are involved in a digital DTMS project. They ran their Frank competition last summer, and we were lucky enough to lead a project and get it accepted. So we're currently leading a UK project called 5G DU Evolution. And the aim of this project is to innovate in the particular focus area of the DU platform. And what we're building this DU platform is, the whole intention of it is to support all-round, very open platforms, but for the purposes of private 5G infrastructure, because we think this is the area that all-RAN is really going to be tested in first. We're working on this project with a range of vendors. We've got some operator support from BT. We've got Accelercom, who are in the room today, Comagility, University of York, Scotland 5G Centre. So it's really across the whole UK where we're getting these supports from. And we're going to build an innovative DU platform. So our vision for a private 5G DU platform, you're going to see some features that you wouldn't normally go to a mobile network and ask for these things. So we don't see people asking for time-sensitive networking on our handsets. We don't see people asking to track the location of the handset to within 1 meter. And we don't see people asking today for ultra-low latency. And the DU platform that we're going to build has all of those features built into it. So it's about building a private 5G network in one single box with the integration of a front-haul gateway, the acceleration components, and multiple compute platforms. So what this is going to deliver is disaggregation of the RAN, so an openness of the RAN, but integrating the infrastructure so that you reduce the physical size and form factor of the build. The idea is to then open up supply chain options. So today we're limited to x86 for all-RAN. In future, we think there are other compute vendors that could be used. And we can't decide which on your behalf. You need to tell us. So the plan is to have flexibility built in from the start so that we can adapt different compute blades. Overall, we think this is going to lead to an improvement in power consumption, in terms of form factor, and also just the overall total cost of ownership. To complement that, we're starting to build integration labs. So we know that a private customer asking for private 5G probably doesn't even know what is behind that term. So they need some guidance in how do they put these functions together that, as I said, may be coming from 3 or 4 different vendors. So we've decided and we felt the need to bring some all-RAN integration labs to bear, one of which will be in the UK and one of which will be in Poland for our European customers. And the whole thing about this is to try and build, ultimately, a private 5G platform that a customer can take in and build it with the confidence that it's been pre-built and tested. So we're going to pre-integrate a set of vendors from the radio unit space, the CU space, the 5G core, and pull those together into a private 5G platform based on all-RAN. And we think this is the way that you can take 5G or private 5G and put it into the private domain with those features that I mentioned around time-sensitive networking, low latency, and UE location tracking. As I said, some of this work is funded by DCMS, Department for Digital Culture, Media and Sport, so I'd like to thank them for their involvement and investment in the project. And hand over to the next speaker.
Ian from BT.
Thank you. Good afternoon. I think everyone's asleep out there. Thank you. So, Ian Newbury. I look after business development in BT Wholesale. I've just returned from 2 years in our media and broadcast division, and it's good to be back. So a little bit about BT Wholesale before we start. Sorry, actually, I skipped a bit there. What I'm going to talk to you today is creating a connected UK. But actually, I want to talk to you about creating a connected, affordable, and sustainable UK. You've heard it from the audience panel today. The cost is high in our marketplace. So, a little bit about BT Wholesale. We've been working with the mobile network operators since 1985. Right back at the conception of Vodafone and Cellnet in the UK. We've got experts, some are in the room, connected across the entire ecosystem, involved in standard setting and just staying deeply involved. And we've got dedicated teams, dedicated to the BT Wholesale and to the mobile network operators across our whole ecosystem. We've been testing ecosystems like Edge, RAN, intelligent controllers for the last couple of years, neutral host solutions, and working with the mobile operators on that. We've got our 21st century network, which is our core network, which boasts publicly of a 99.999% availability. The last time I checked the performance of 21C, it was delivering at 99.99996, which equates to 12 seconds downtime, or 12 seconds lost network time per year. I'll wait for someone better at maths than me to correct me on that one. We have a 24/7, 365 operations centre, except on leap years when we put in an extra day, and we've delivered over 100,000 services for the mobile network operators. 21C is the largest network in the UK, not just in the size of its scale. It is the only network that, if you take away the map of the UK underneath, it will also still look like the UK, but also in terms of capacity. We're carrying about 4 terabits plus peak capacity on mobile traffic, and we've carried, I think last week, 27 terabits in total across 21C at peak. That 27 terabits includes TV traffic, broadband traffic, voice traffic, business Ethernet, and of course the mobile network operators and the emergency services network. So we're at Small Cells World Summit, so I should talk a little bit about our small cells portfolio. So we're really privileged to be working with all 4 of the UK MNOs. We've got relationships with 3, VMO2, Vodafone, and of course B&BT, relationships with EE2. And we've got different types of small cells deployments with all of them, ranging from 100 meg solutions to 1 gig, all the way through to a C-RAN proof of concept we're currently running. We've got what we believe is the largest asset database in the UK. We've got access to over 5 million assets. Those range from telegraph poles to telephone kiosks to council concessions and beyond. And we offer everything from a single access service all the way through to a full turnkey solution. And just at the bottom there, I was going to talk about some of the things that we've achieved in the market as a kind of greater good for everybody. So we were the pioneers of open access. I don't know if Ali's in the room somewhere, but Ali Akhtar in my team actually came up with the name Open Access. And in 2018, just check my date, we handed back our 9 concessions to local governments to promote the use of open access, which is to stop land banking and make sure that assets were available to all at an affordable price. We've worked with industry to create the world's smallest 1 gig phase-capable NTE. My colleague to the right of me, Anthony, was involved in that. It was ADVA whose NTE is on our stand if you look at the lamppost. If anyone's interested, it's called the FSP 150 Go 102 Pro. I was coached before the meeting with Anthony to say Go 102 Pro because apparently there's a camera manufacturer that get a little bit upset if we call it the GoPro. As I said, we've got the C-RAN trial live now. We're going to look at the economic benefits. We're going to look at the technical benefits. We're going to look at the coordination benefits. We want to make sure, before we start developing the solution, that C-RAN is actually going to deliver the promise that C-RAN is offering. Then finally, we've got the UK's largest network-based phase solution. This solution is a wholesale solution like all of ours, so it is available to all. It can traverse anybody's fibre, anybody's equipment, as long as it's compliant to the boundary clock and the standards. And we think this is going to be really important as we evolve to a heterogeneous network when you're moving across multiple domains. But when we think about our high streets, the green cabinets on our high streets, the duplication in build, the disruption, there's a question for everybody here, from local councils to equipment suppliers, to fibre providers, to infrastructure providers, the full ecosystem. If we were starting from scratch today, would we build in the same way that we're currently building 5G? I hope everybody in the room would say no. So just for a show of hands, would anyone say we would continue? Okay, good. I was going to walk off the stage if they were going to put their hands up at that point. So, when I look at the UK in numbers, the mobile operators are all boasting better than 99% population coverage across the UK. 99%. But we still seem to be in a coverage war. We still seem to be announcing these successes in coverage despite the fact we're all going to end up in the same position. You know, I'm sadly old enough to remember going into a mobile phone shop and looking at a map on the wall and trying to work out where my family lived and where my friends lived so I could choose which mobile phone network to go with. We're not at that point anymore. Worse than that, 49% of macro sales, we did a subset of data, about 4,000 sites at random, 49% of macro cell sites are within 50 metres of each other. That means we've paid for 2 sets of fibre digs, 2 sets of trenches, 2 sets of access services, 2 towers, 2 cabinets, 2 sets of power to be running. And all of this using the same resource. So we're stretching the resource. It's great in the small work contractor base. I'm sure it's driving that price up of demand. But for the mobile operators, it's hurting. And then when we look at the future, when I combine what I've been told by everybody since I've been back in the industry, we're predicting 40,000 to 80,000 small cells outdoor by 2026. That's between 10 and 20,000 a year. That's a scale that we've never built on before. And on top of that, 100,000 indoor small cells. If you add a little bit of complexity into that, you've got the, I'll just check my maths on this one, you've got the 10 microseconds latency between an RU and a DU split, so you can't even go deep in the network. So I know I'm not alone in my thinking, because I've heard it from my colleagues on the stage today. I think everybody on the stage so far has had a similar message that we've got to do something different. 5G has to be affordable. Nick reads for the CEO of Vodafone. I'll give you a moment to read that, and that'll help. Returns on capital in this sector in Europe have halved over the last decade. The sector is destroying value by duplicating infrastructure. We need to move to a better model. And if I stop for a second, I think, what are all the 4 mobile network operators' mission statements? And I had to write them down because I can't remember them yet. BT's, I know, we're connecting for good. There's a huge push on a better socio-economic UK coming from BT. Vodafone's, to connect for a better future to drive positive change for society. The same, but different. Virgin Media O2, using the power of connectivity to supercharge communities across the UK to close digital divide. And then you've got 3, better connectivity every day for every customer. Our purposes are very similar, if not the same, in that we're trying to build a better UK and a better socio-economic, close the digital divide. But when I look at that building in the same locations, it feels like we're building in the same locations at a different time and creating a big problem for ourselves where we could build together. So what can we do differently? I think probably everybody in the room will have a different opinion on this, which means that there's a lot of great thought in the room, but just some things from BT. So I'm going to start with the sites piece, so the assets that we build on. Open access, we've got to support the open access model. We've got to not sleepwalk back into a concession model. We've tried the concession model, it's expensive, it creates what they call land banking, which is where you can't actually afford to go on an asset because the price the concession holder has to recuperate is prohibitive. This created some great innovation around resectoring macros for 4G, but for 5G, we can't just keep resectoring, there's just not enough space. So we've also got to remember that open access, whilst it's the right idea, the code hasn't been the panacea that the mobile operators were hoping for. We're still finding long negotiations. We're still finding that things are being held up. We've got to work closer together as the entire ecosystem, not just the mobile operators versus concession holders, to improve the process between us all and move forward. We've got to promote the socio-economic benefits of 5G. 5G's received some bad press, as I'm sure we've all seen over the pandemic. We've got to promote what it can actually do. And a couple of stats I pulled out from an event with the Royal Docks in London last week was 82% of jobs require digital skills. Jobs with digital skills pay on average 29% more. That equates to about £8,900 a year. Families without digital skills pay on average £500 extra a year on their utility bills. We can't afford to create connectivity deserts. We can't afford to enlarge the gap between society. We've got to work together because we've got the opportunity to close that gap. And to that end, we're working with the DCMS. We're involved in the DCIA, apologies for the acronyms, project, which is looking at how we can build a template for the UK to work with local councils. How can we pull it all together and simplify we work? I think anyone involved in supplying small cells and macro cells will agree it takes too long. It's too difficult. It's too much variety between each council, and there's just too many barriers. And we'll work with vendors like probably everybody in this room today on neutral host solutions and open RAN solutions. This is to make sure we don't end up with every lamppost down a street with a small cell on it. We could do a combined radio unit, neutral host, all 4 operators, and if needed, a private network in there to save space, save clutter, reduce carbon footprint, and just make it simpler. Less digging, less patchwork pavements, and just really simplify the deployment process. And finally, when we've got all of this fixed, so sometime next week, we need to look at the whole end-to-end processes and drive efficiencies into that to speed us up. So on small cells themselves, I've picked 3 models here. The first one is rural. I think the rural argument is, or the rural architecture on CRAN. And the reason I've gone with CRAN for this and not distributed RAN is I haven't seen yet a single distributed RAN small cell, but I do have to scout the room again later. It looks like for 5G, we are going on a CRAN journey. But when I look at a macro site in rural, or a small cell in rural, having the radio unit and the distributed unit on the same site, that works quite well. You don't have the big coordination benefits of multiple radio units from multiple adjacent sites. So that problem, that solution is fairly set. The only real question is a real-time, the RAN interface, RAN intelligent controller, sorry, which is got a latency in the about 100, well, it's in the milliseconds, so it's not a huge problem as long as you can get to the local exchange. When we look at the urban, however, we can look at front haul and move the distributed unit back into the exchange. We're still okay because you've got about 100 microseconds latency tolerance on a radio unit, distributed unit setup. And if you look at fibre, it's about half a microsecond per kilometre of fibre, so you could still situate the distributed unit in the local exchange. And then you get your clusters. You can really start to get these benefits of coordination and getting more out of spectrum. Then finally, we've got the urban small cells model, and that's very much about clusters of sites going into a cabinet, which then goes back over mid-haul links to essentially local exchange. Now, the challenge with that is these cabinets are about the size of a payphone. We're not going to be able to get away with putting a separate payphone-sized cabinet 4 times on the same street, or 2 times on the same street. We wouldn't be doing our social good if that's our plan. And this is where, for me, Open RAN really does come into its own, because we've got a choice. The mobile operators can choose their own radio unit vendor, or we can agree on a neutral host radio vendor. The distributed unit in the exchange, that can be a different vendor that we all agree on, or we have separate software instances, but we can do that on the same server in that same payphone-sized kiosk. And then when we get back to the centralized units, the mobile operators have the choice of doing their own, or if you're going to bring them deeper into the network to the exchange type level, then you can, because of the RAN intelligent controller's got the lower latency, you can put your centralized units there, but everyone can have their own instance, so the MNOs create or keep their ability to compete. We're not asking people to do the same. We're asking where we're building in common and where it's non-contentious, let's work together and let's improve what we're doing here. The density will determine the architecture, as I've shown on this slide, but we've got to work closer together. And I really do think that if we're ever going to see the benefits of Open RAN's 30 to 50% savings, we've got to start talking now. So, finally from me, just some ideas of how we can help. So we've got 1,200 exchanges locally, nationally. All 1,200 exchanges are within the latency requirements of the RIC, and the DU. We've got low latency over those links, but we've also got low latency across the 21C core because the 21C core is built to be a mobile network core. It carries the ease traffic by default, as well as other mobile operators. We're launching later this year, so my product leads at the back of the room, she'll tell me off if I say we've launched. We're launching indoor neutral host this year, and that will have the capability for all 4 mobile operators on the same equipment. We've already launched a shared outdoor solution using a wavelength product to make sure that all 4 operators can use a common access method. And we're currently in a proof of concept with CRAN right now up in Leeds, which I'm sure we can invite anybody interested to come and see. We've got the first 3 sites live. We've got another 3 or 4 to go live on it to get the true coordination benefits out of it, but we're going to learn from that to make sure we develop the right solution. And we've launched our network-based phase solution, and that is available to everybody. It's not a BT-only solution. We build so that to wholesale. It's in the name. And all of that is backed by the UK's largest asset portfolio. Thank you.
Thanks, Ian. So next, we're going to have a panel session focusing on enterprise service delivery. I'm going to kick off with a couple of questions for the panelists, but hopefully the audience will have some questions as well. So hopefully we have a mic somewhere. But I'll start. So I'd like to introduce Dennis Miranda as well, who hasn't presented this afternoon, from Ericsson, and I'm going to start with you, as you haven't had much to say so far. And we spoke there, we've all sort of highlighted various challenges with delivering sort of private LTE, private 5G to enterprises. Technical challenges, commercial challenges especially. And I think there were a few areas in your experience that you wanted to talk about there in terms of the technical challenges.
Yeah, good afternoon, everyone. Definitely, there's been, with the experience from Ericsson, what we've noticed is that, yes, today we just named the cost and the technology and the different modes in which we can implement the networks. But there's also one component which was mentioned as well, which is it is the use case that drives the implementation or anything. The enterprise is not going to implement. First, they are not familiar with the technology. Here we are a community and with the MNOs that understand 3GPP for many years, and now we're introducing the goods of that type of technology to the enterprise market, and they are totally unaware of the capabilities of what is possible with that type of technology, never mind with 5G, which comes with all these promises. So on top of everything that has been mentioned, one of the things that we notice out there is we need to have an academic approach to private networks, to enterprise private networks, to really enable the enterprise to understand everything that is possible on this type of networks. They've tried with Wi-Fi, new specifications of Wi-Fi are coming, etc. But the reliability is not there. The low latency, the security, data privacy, all these issues in particular, if we're talking about very advanced industries, for example, in Germany with the big car manufacturers, they're really, really careful about keeping data local and having ownership of the network, of the data, of the control of that network. So it's very important that as a challenge, it falls between the technical and commercial, but it's the education and the enablement that we need to create towards those enterprises. And this is a new market. We are creating that demand, and it's part of our responsibility, basically, to push this technology in that mode.
Yeah, valid points. Andrew, is there anything in terms of the challenges that you'd like to add to that, in terms of the experience BAI has with transit networks and the smart cities case study?
Yeah, sure. I mean, and also from a private networks angle, from an enterprise angle, and I think a lot of the panel have said this, so it will probably sound like a broken record, but last week, Tech UK issued a private networks guide or report for all of the perplexed people out there in enterprises, scratching their head at the moment going, I really need one of these things, but I don't really know where to go or who to speak to. And I think there is a lot of complexity in the industry that we're beholden, we have to simplify it, I think, for people that are out there at the moment wanting or think that they need a private network. And I think it all comes back to what is the business problem that you're trying to solve, first and foremost, and therefore the type of network that you're going to need. Is it some sort of like supercritical application that, is, loss of life, and you need that instant response? Is it something in manufacturing where you need that kind of really super fast latency issue? Or is it something where you need a seamless handover with the wide area cellular network. You know, so first of all, you've got to decide which bubble you're in and really try and simplify down what the problem is that you're trying to solve before you jump into the tech. So that's what we're sort of seeing from a BAI perspective, that, you know, we, you know, first of all have that pause before jumping in and you know, starting on the O-RAN, C-RAN, D-RAN sort of journey.
Yeah. Thank you. Any questions from the audience at this point? No? Oh.
Thank you. Ian, you mentioned about building for good, and I think, Andy, you were talking about DAS and small cells. I was interested in your views about energy efficiency and energy consumption in the, following up on the previous conversation. How does DAS compare with small cells from your experience, and how does Open RAN allow you to reduce energy and CO2 emissions?
Yeah, I think that's a really good question. I mean, you know, right now we're deploying digital DAS in the capital, really high-tech system from a supplier in South Korea. We definitely see that there's a kind of roadmap, a glide path to using more efficient topologies over the next couple of years. Now, there's a lot of work that's been done with the neutral host in building JOTs, which we'll learn about more this afternoon. And I think this kind of like vRAN technology, it's starting to kind of like compress the tech so that, you know, you can fast forward. And well, actually, we already see instances now where, you know, you don't need the monolithic BTS stack on the mobile network operator side. So I think it's one tech to watch. We don't think it's quite there yet for a vast deployment, but it's something that's accelerating, and that will inherently shrink the BTS footprint and inherently the CO2 footprint.
I think I agree with Andy, but I think I think there's two ways of looking at it. The first way is the equipment. So if you look at O-RAN, C-RAN, neutral host in building, all of those are lower power than the digital DAS solutions. What I've seen, and I think stats up to 50 to 60% less power. BT, not to plug BT, but we've got this carbon neutral approach to everything we do. We beat our timescales on being carbon neutral, so we're trying to oversee those now. So everything we do is looking at that. So the first side, I would say, is the neutral host in building, the C-RAN, the O-RAN, will lower that power consumption, will lower our carbon footprint. The second side of it is, if we start working together more, and we have more like a neutral host in or out building, radio unit, that's 3 less units that will end up in a landfill at some point. If we have one server with 4 software instances of distributed unit on it, that's 3 more servers that are not going to end up in a landfill. The example continues if you put a private network on there as well, if you extend it to Wi-Fi. So it's a great question, and I think it's both technology, and we have a responsibility to each other and the UK to drive technology into shared solutions.
Thanks. We have another question over here.
Assalamu alaikum and good afternoon, ladies and gentlemen. This is Mahmoud Khatib from Tawal Saudi Tobacco Company. I have one question regarding the roadmap of small cells. What can we see right now? We have a lot of vendors located in this market, and we can expect that there are some demands in the future regarding the massive deployment of small cells due to the mass traffic or mass events. Okay. For example, we have some demands to have a small cells with high bandwidth, more than 300 megahertz per small cells. Okay, from O-RAN point of view, or C-RAN, or vRAN, or specific vendors. Okay, still till now we could not find specific vendors that have a roadmap for such demands in the future. which we're expecting that within 3 to 5 years, there will be huge demands in small cells, especially related to coverage point of view as 5G demands for millimeter wave or C-band. Thank you.
Who would like to?
So I think the question was, there's a big demand, there's a lot of people in the small cell vendor space, but who can deliver the demand of those 40 to 80,000 small cells and 100,000 small cells we're looking at? Is that correct?
It's mainly related to the roadmap of small cells. What can we see after 3 or 5 years? For the product point of view, especially for the bandwidth. As we can see now, we have a lot of products from different vendors, but no one is focusing on the bandwidth itself. What can we see? We have different products, specific with different shapes, but still there is a limitation or restriction on the bandwidth.
So I think we're going to, this is personal opinion here, with 2 months back in the fold. I think we're going to be rolling out 4G small cells for a little while to come now. The 4G small cells, we're still in that adoption rollout phase, and the focus at the moment is the 5G macros. That does need to pivot to a 5G small cell. If I look at the small cell roadmaps that I've seen so far, they're all focused around centralized RAN, and there's certain reasons. One reason people are saying is the distributed unit and the radio unit in the same unit would just be too big and too heavy. Other people are saying it's how you're going to get the coordination benefits that 5G have got to do. The longer term roadmap for small cells is probably a good question for Anthony, but I think it's a little bit still in the build it and they will come. We'll start rolling them out and find out how effective they are. I don't know if you saw today, there was a quote from Cellnex in the media saying they felt that for every £1 spent on a small cell versus a macro cell, you got 45% more value, I believe is the stats, and I can share the paper if anyone wants to see it. So we know when people are testing the small cells and they start seeing those benefits, that will drive the demand and that will drive the roadmap. On top of that, the use cases will drive the roadmap as they develop. But you're right, there's not a great deal after kind of the CRAN 7.2 split that I've seen so far. But I'll turn over to somebody that builds these things.
So I couldn't fully hear the question, so apologies if I'm answering a different question here. But what I would say is that the small cell market that I see is really 2 components of that. There's the people that have deployed small cells, fully integrated, radio unit, DUC, or layer 1 to 3 in the radio. And then we see the all-RAN guys trying to build something like a radio unit. That's the halfway house of putting an option 6 split on and having what I would call RDU functionality on a radio. And right now, what I'm seeing is 2 different poles. If I go out and try and find a radio that achieves, let's say, interoperability across different all-RAN standards, so effectively what we're hearing from our customer base is we think we want to do small cells in private 5G. We hear from the operators that they're not ready to deploy all-RAN yet because it's not mature. So my gut feel is if I was trying to produce a roadmap for a radio for all-RAN or small cells, I'd be saying in general, small cells fully integrated don't give you the level of coordination that an operator craves. So it's unlikely to be that the operators deploy. All-RAN isn't mature yet, so they can't deploy that either. So there's going to be a waiting game. Somebody needs to mature all-RAN first. So I think the enterprise community is probably that testing ground for all-RAN. So I think you'll see pockets of all-RAN in campus networks, private 5G settings, and then you'll see a carrier version of all-RAN move into the macro cell and small cell network. But I think you're 5 to 7 years away from that.
I think we have to wrap up there. We've run over a little bit. I'm sorry because I missed a couple of questions there.
Don't worry, I'm chairing the next session.
Yeah, okay. Okay, but I'd just like to thank our panelists and presenters this afternoon. So,
Thank you.
round of applause for the panelists, please.